Okay, hello everyone. I am Shekhar Sharma, first year student at BIT Mesra of ECE branch. I am very excited to dive into one of the most essential components in electronics, that is inverting operational amplifier. In this video, I will explain what an inverting operational amplifier is and its working principle and its importance. Let's simplify it. Like we know, op-amp is used as a high gain amplifier, while inverting op-amp is used to get constant gain. Now first we will see the construction of inverting operational amplifier. Here positive terminal, that is non-inverting input, is grounded and we are supplying voltage V as an input from inverting terminal, that is negative side. Also we added R1, and from the output voltage some signal is transferred back to input followed by RF, that is feedback resistance. As the gain of an op-amp is very high, as much as 10 raised to power 5 to 10 raised to power 6, even after we applying a very low input as a supply, this gain is very high and is of no use in real life. It is very unstable and very hard to control, as the smallest of input signal, just even a few microvolt, would be enough to increase the output voltage to the higher level. That's why we need to know about this configuration, that is inverting op-amp. As the open loop gain is extremely high, we can therefore afford to lose some of this high gain by connecting a suitable resistor across the amplifier from the output terminal back to the inverting input terminal to both reduce and control overall gain of the amplifier, and we generally call it as a negative feedback, through which we are just feeding back a fraction of output signal back to input using an external feedback resistor, that is RF. Now before proceeding into the derivation part of closed loop gain, we will see a small concept, that is virtual ground. Now if we see the diagram, here positive terminal is grounded. Let's consider we are getting output voltage is equals to 1. So we can say output voltage, that is V out, is equals to A into V in, and we know gain is a multiple of 10 raised to power 5 to 10 raised to power 6. So let's say gain is a 10 raised to power 6. So here we go, 1 is equals to AV in, and here we are getting input voltage is equals to 1 microvolt. That is very small number. So we are considering 1 microvolt is equals to 0. So here we are getting Vp is equals to 0. Now what is closed loop gain? Let's say current I is flowing as an input current, as we are talking about a real life op-amp. Here we will apply Ohm's law. So by applying Ohm's law, we get I is equals to V1 minus Vp by R1 is equals to Vp minus output voltage, that is V out, divided by feedback resistance, that is RF. As we have studied the concept of virtual ground a few minutes back, so we will apply that concept here. So by the concept of virtual ground, Vp is equals to 0. Now we will put Vp is equals to 0 in this equation. So we get V1 by R1 is equals to minus of output voltage by RF. So finally we get V out by V in is equals to minus RF by R1. Previously we studied V out is equals to AV in, that is output voltage is equals to gain times input voltage. So we can say A is equals to V out by V in. Now apply this in this equation, we will get A is equals to minus RF by R1. That is the gain of inverting operational amplifier.